CIT 1122, Module 2. We're going to do this whole thing at once because this is a really short chapter. It just talks about switching concepts. There's not a whole lot in this section. Oh, my video is, my lines are off just a little bit. There we go. That's a lot better. Now it's right in the middle. I like it. Okay, so there are two parts here. There's frame forwarding. It talks about switching domains. We're going to talk about each one of these. I do have some supplemental videos that I'll post with these as well, where we talk about ARPing and how ARP works. But at the beginning here, when it talks about frame forwarding, it gets into the concepts of ingress and egress, which is a really highfalutin way of saying inbound versus outbound. So ingress is inbound, egress is outbound, and it talks about how it is that a switch works. And switch's function is really, really simple. It uses a table, and it associates the table with a MAC address. And when information arrives, the frame header is read and the destination MAC address is identified. And that destination MAC address is looked up in the table, and then the information is forwarded out the interface with the associated MAC address. Easy enough. So that is how we're going to send everything away. So egress. We get something in, then we want to get rid of it. We want to move it out to another interface, and off it goes. The table itself is created through learning the addresses from the source MAC address. So when a device first turns on, and like I said, I don't want to get too deep into this because it was in other videos, but there's something called a gratuitous ARP message that is used. Gratuitous ARP is a message that is sent that identifies or checks to see if another device on the network is using the IP address that that device is using. So let's take an example. A PC has an IP address of 192.168.10.1. The PC wants to make sure that it can communicate on the network, and it wants to make sure it's the only 192.168.10.1 that is out there. So what it does is it sends out an ARP broadcast. It says, who is 192.168.10.1? If you happen to be 192.168.10.1, then please respond back. And it waits. And if that message times out and nobody gets back to it, then it says, okay, then I'm good to go. I'll be able to participate on this network. I am going to be 192.168.10.1, and that's my address. If another device responds back to that gratuitous ARP and says, actually, I'm 192.168.10.1, then the rules of TCP/IP state that the computer or device that was trying to use that address, if the gratuitous ARP comes back, someone responds to it and says they already have that address, then that device, the second device that's trying to use that IP, cannot join the network. So it can't use that address. And that's what gratuitous ARP is. So it ensures there's no duplication. Now, what a switch does is it leverages the fact that a gratuitous ARP is going to go out. The gratuitous ARP is going to identify the source MAC address. And even before this machine can even participate on the network, the switch is going to read that source MAC address for that gratuitous ARP, and it's going to identify that, and whatever interface that machine is plugged into, it's going to put that MAC address on that in its CAM table for that particular interface. And that's how it figures out how to send stuff from one place to another. So, and if you took a switch port and you unplugged a cable and then plugged it in someplace else, that network interface card would lose its power. And then when you plug it back in, it would power back up again and it would say, oh, hey, I just joined a network. It would run another gratuitous ARP. So every time the electricity starts or stops on a device, or if it gets an IP address, it sends a gratuitous ARP, which can be used by the switch to learn the source MAC address and associate it with a particular port. All right, good enough. So that's that. So now we got CAM table, that's done. Whoops, went backwards there. And the next thing is store and forward versus cut through. So there's a couple different methods that you can use to forward information. This is a really nice slide that identifies a protocol data unit. You've got your frame header up at the front, and then you've got your network header, your packet header, your segment header, your transport header, and then you got your data after that. So the beginning of this protocol data unit is on the left-hand side. Now, What they've done is then they've blown up the fields inside of the frame header. The first field inside the frame header is called preamble, and that's just a synchronization product that's going to allow your devices to know when to start reading. And then there's 3 fields inside of the frame header. There's destination MAC address, the source MAC address, and the type field. And the type field's job is just to identify what kind of information is in the network header. Great. So what we're getting to here is this, is a switch can start forwarding information as soon as the destination MAC address is read. So in this case, really right here, this is where we could start forwarding, because now once this value is read, the switch is going to know where to send the information. And at that point, right there, let's draw a big line there. Right there, it could say, okay, let's check our lookup table and let's just start forwarding this to wherever it is it's supposed to go. And that is called, oh my gosh, it's not storing forward. Storing forward says read the whole thing. That is called cut-through switching. Holy cow. So yeah, cut-through just means we're going to read the destination MAC address and we're going to fire it off to the destination. If we read the whole thing, hey, let's pull the whole thing into memory, and let's go all the way to the end, make sure there's no errors, and then we send it. So instead of reading this much and then forwarding, what we're going to do is we're going to read this much. We're going to read the whole thing and then forward it. That's store and forward. So store and forward versus cut through is just how much of the memory are we going to use from the switch. Cut through, not much memory. We're just going to go straight to it. Store and forward, we're going to use a lot more memory. We're going to make sure there's no errors. The default method is cut through. Okay? Keep that in mind. Since we're here, let's just go through switching domains real quickly. There's only a couple of slides here. So there are collision domains, and then there are broadcast domains. When they talk about a collision domain, they're talking about the concept of a device having to wait to send information to another device. When you're connected to a switch, the collision domain is its own device. So a device can't send or isn't going to send information to itself through the switch. So there aren't going to be any collisions. The switch handles the communication path between the PCs. So there will not be any collisions. There's not going to be any collisions when we're connected to a switch. When there was a time before when we had a hub, only one device could communicate at the same time. When you use an access point for wireless communication, there is another method that is used where we have a time of contention followed by communication. But as far as collisions go, there's no collisions with switches anymore. So the switch is going to manage those, and it's going to remove any kind of collision. So every device is in what's called its own collision domain. So if you wanted to count how many collision domains there were connected to a switch, just count the number of cables coming out of the switch. That's how many collision domains there are. The other thing that they want to talk about is broadcast domains. Broadcast domain just means this. How many devices are going to receive broadcast messages? IPv4 and Ethernet are broadcast technologies. So we talked about ARPing before, and we talked about gratuitous ARP. A gratuitous ARP is a message that has a destination MAC address of all Fs, and it's going to go to every other device on the network. So if one of the devices in one of these diagrams wanted to send out a message, the other ones would get it. So in the top diagram there, one device sends something out, the other 4 devices would get that message. It would get that broadcast message. And that's great. And the only thing to remember about broadcast domains is all the devices that are connected to the switch should be in the same subnet. So one broadcast domain equals one subnet. Can a broadcast domain span across a couple of different switches? Sure it can. So in the lower diagram, it shows 2 switches connected, and they are connected, and all the broadcasts for any device that sends a broadcast on switch 1 would go to not only the devices that are connected to switch 1, but also ARC all the way over to switch 2, and all the devices connected to switch 2 would also receive that broadcast message. Easy enough. If you get too many devices connected in and they're all broadcasting all the time, it's going to create a lot of extra traffic, and that's kind of a bad thing. So we want to try and keep our broadcasts smaller. But like I said, the other thing is, as far as broadcast domains go, all the devices in the same broadcast domain are going to be also in the same subnet. Okay? All right, that really knocks us out of chapter 2 or module 2. It's a pretty easy module, and I'll see you in module 3.